Tommy, welcome to the show.
Thanks, Steve. Glad to be here. Been a long time coming, so glad we can finally do this.
Yeah, I know I've been kind of bugging you for a couple of years now, right? And you've been restricted, so it's good to have you on and share your story of your background and what you're up to next. And I was thinking about it a little further when we met, when we were both at Spectrum, you kind of Apollo at the time, and me, Adam Spence, and that merger. And I think I remember you visiting the Adam Spence facility, and you had a lot more hair than you had long hair, we'll say, then I remember. But
Yeah,
I was,
that was a while back. That was a good visit. It's always fun to see new facilities with different equipment and different processes. That was a good time.
yeah, I was thinking about, that Oceanside Apollo Spectrum, we'll say, a site that you worked in, and the talented people that you worked with, right? If you think about you, Bobby Weiner, who ended up working for me, great guy, great engineer, and Mike Schultz, Eric Wendehost of sales,
Yeah.
David Kramer, Tyler Stark, and of course Matt Bill's kind of running the show and in the background in Sandy. But what a great group of people.
Oh yeah. No, it was. I learned a lot there. I mean, it's crazy being at a contract manufacturer and just getting to see hundreds of designs, and you learn quickly and fail fast. So it's a pressure cooker of learning there for sure.
Yeah. Tell us a little bit about your background, starting with, I think if you want to start there. And you
Yeah.
had a great run at Inari and Stryker, and then we'll go into what you're up to now.
Yeah. So I was a medical device engineer or catheter engineer at Apollo Medical, where got to work with a lot of the big OEMs designing hundreds of different catheters. I'd say kind of our specialty at the time was steerable catheters. From there, moved on to Inari Medical, where I got to design many next-gen thrombectomy devices for the treatment of pulmonary embolism and deep vein thrombosis. And it was definitely amazing to get to see the other side of the puzzle too. I think a lot of contract manufacturers don't realize how much they're helping people. You don't necessarily get that side of it. So getting to work for an RE, seeing the patient impact, going to cases, working with doctors was truly special. Getting to patent several devices and catheter manufacturing methods. Worked as director of R&D engineering there for a while. Had a great team working on process development, and now on to the next adventure.
Awesome. You talked about how some people don't have that appreciation, from a contract manufacturing side, with the OEM side, and what the devices are and the life-saving applications. And part of what we're going to talk about is communication, right? And DFM, right? But it's also really important to understand not only design for manufacturing, but what the therapy and how they're affecting patients directly. So that's a good point there.
Yeah, no, and I think we'll get into it in a little bit, but yeah, I think a lot of the times these contract manufacturers have their hands tied a little bit because of the information they are not getting.
Yeah. So let's talk about what you're up to next. It's new venture, CathTeam. It sounds pretty exciting. There's certainly a need for training on catheter technologies, the basics to the more advanced, like you mentioned, steerables. And, there are some training opportunities out there, but I think what you're going to bring to the table is a little bit more hands-on, applied with equipment and having your own site. So share with pretty exciting opportunity that you're creating.
Yeah, so early days, but CathTeam is going to be a training facility. We've got all the equipment. We're going to have braiders, coilers, lamination equipment, all the real deal that the large OEMs are using in their manufacturing processes. Planning to offer single multi-day trainings on catheter design and hands-on manufacturing. So I think connecting those two pieces is a big deal, because it's one thing to design behind a desk, and it's another to actually go make those devices. And those two really go hand in hand, because the way you're making it affects a lot of your characteristics. So you can't necessarily do one without the other. So I think it's really important that we'll be able to be in a classroom setting, do some design training, and then move over and like, let's hop on a braider and actually make it. Then let's laminate it. Let's see, what issues arise. Do we get bubbles? How do we fix that? So I think there's a lot of interesting things we'll be able to do there. Certifications for people to, put on their resume, or, hey, you're a certified, braider one technician. So really excited to work with local engineers, technicians, and operators on various trainings on catheter design and manufacturing. So a lot of exciting stuff there. We'll have a little bit of maker space capability if you want to come in, utilize our space for new equipment training, new processes, you name it. And then we're also working on some complementary services as well, such as some software and toolkits. So
Awesome.
a lot of exciting stuff, and it's early days. So, things will change here and there, but that's the current plan.
How are you planning on kind of going through the coursework? I know everybody wants to be involved with the next generation steerable catheter or AI guided tip deflectable device, but going back to the basics, you have to really nail it right. Pushability, torque response, kink resistance. Talk a little bit about kind of some of those basics as a firsthand.
Yeah. And, I think those are really important because I think a lot of engineers understand how to build a really complex catheter. They've designed something at a company where they made a very complex steerable or electrical based catheter, and it does amazing things. But then some of the fundamental things are missing, the PPI of a braid, the pitch of a coil, different durometer choices. There's so many decisions kind of in that early development cycle that you need to understand, and so many things that I'm hoping at CathTeam to kind of, okay, let's take a step back. Let's learn some of the early stuff so that can help you down the road. Because I think there's a lot of complex designs that could be done a lot more simply by understanding these concepts. And in that early design phase, it'll help you narrow down kind of your decision making as well.
Yeah, and you mentioned how, you'll have braiders and coiling machines and other catheter manufacturing equipment. You talk about picks per PPI and pitch on a coil. I guess you'd be able to kind of hands-on see how a machine you can affect those changes on the machinery directly.
Oh yeah, one thing I'm really looking forward to is, hey, we've got a group of 8 people and let's all build a slightly different catheter,
Mhm.
and then we'll do the testing at the end and see how it affected the results, graph it, and it's like, hey, look, this is directly how PPI or, a single change or a couple changes affected the final results of the catheter, and to see how extreme those changes can be as well. So I'm really excited for that. And then just, training on a lot of the slightly more complex stuff as well. One thing I love talking about is triaxial braiding and how underutilized that is. You're in the extrusion game,
Yeah.
multi-lumen extrusions aren't always the easiest thing to do. And I think a lot of people don't realize they've got this braiding equipment out there that can go ahead and make extra lumens with it and a smaller profile. But you need that expertise to be able to do it. But it can save you a lot of time and effort with multi-lumens. Multi-lumens have their place, but I think being able to braid or make lumens with your equipment that you already have in-house is a very nice process that can lead to some really nice characteristics in your final device as well.
That's a good point. You're in particular, maybe you're talking about steerability, right? Sending some steering wires through like a triaxial in the braid, as opposed to creating a custom lumens on the outside peripheral to do the steering. And
Yeah.
certainly makes it easier, right? When you talk about understanding the parameters and then applying the equipment, but also DFM, right? Design for manufacturability. How do we make these things as cost effectively so that we can scale?
Yeah, that's always tricky. But understanding that equipment, you see a lot of processes. For example, the braiders can do continuous braiding. Not everybody's utilizing that. They'll take a discrete length and they've got an operator sitting there cutting it. And
Yeah.
there's a lot of opportunity to make these things better and do your process development early on in your design. Understanding the process development early can make your manufacturing easier down the road. If you're picking something that's inherently complex, that's what you used on another design and you're trying to apply it there, you can end up with really difficult process development that isn't worth doing. Or, building in too many manual processes that are very difficult for operators, make it difficult for training. So it's nice to understand those complexities early on so you can design around them or design them out even if you need to.
Yeah, I suppose that you could also look at kind of some of the failure modes on a catheter, right? We hear about tips detaching, kinking, of course, bonding or delamination is a big one. So covering some of those, failure modes is very important as well.
Yeah, and I think there's kind of two major things that I've seen happen. You have a device that gets used by a doctor off label, can't really control that. It's going to happen for a variety of reasons, or maybe the device sees some anatomy that wasn't quite anticipated. And one thing I'd like to do at CathTeam too is, by understanding a lot of these early concepts for the braid, coil, different metals, plastics, you can really make your device overly robust, so that it's not going to fail in those moments and everything's going to work. You're not leaving any tips behind, any devices behind, anything like that. And then I think the other failure mode that we see is all around joints.
Mm-hmm.
You've got a joint here, 2 P-backs is maybe, and that fails because it falls apart. And I think what I saw a lot when I was at Apollo is we would get a print and everyone would put multiple transitions in one spot. For example, a braid would stop, then a coil would start, and P-baxes would change at that same spot, or you'd have a lot of different things going on at one point because it's easy to communicate it that way on a print. But you put all those different materials and all those different steps and all those different manual processes in one spot, and you're just asking for a failure mode. So I think designing around those weak points in your catheter, staggering them around, making sure they're all safe, and then really understanding your manual processes and going your operators, hey, if you see this, it's not going to be good. Like, these things can't be reworked. These things aren't going to work. This is what's going to lead to a failure. This is going to what lead to a tip getting left behind or something like that. So I think those are kind of the two major failure modes I've seen most, is kind of the misuse or overuse of a catheter, and then kind of not designing around those joints as nicely as you could.
It's probably even more important now with the advent of these PFAS-free materials that could potentially replace PTFE. So we're working with new materials and bonding, and also the increased use of laser cut hypotubes as a reinforcement or a backbone, as opposed to a braid or coil or a combination of thereof. Kind of brings into some new opportunities and challenges always with some new materials.
Yeah, the PFAS free one is going to be interesting. I've heard different takes where, it's going to be fine, or, it's not. Medical device industry is, yes, a lot of single-use plastics, but it's saving lives. So, I think it's a little bit different. I'm hoping that, PTFE can continue to be used. I think it's kind of one of those super materials we get in these catheters now that's getting down to tenths of a thou thick. And it's just incredible and hard to beat. And, when you go away from that PTFE liner, using P-backs and other materials definitely adds complexity to your designs and your process development. It is not easy. It's definitely not easier to use a P-backs liner or other type of liners. So we'll see what happens there. But, the field's changing every day. There's new processes, materials out every day. So it'll be exciting to design around that in the future if we need to, or see where, what PFAS-free things come out anyways. I think it's always pushing the boundaries.
Yeah. You mentioned the wall thickness, right? That's one of the things people kind of forget about PTFE, whether it's a film cast or a ram extruded. The wall thickness is for low profiles, thou and a half below, down to a half thou. You can't get that in these P-backs or nylon type extrusions. Not even close, really.
Not yet. But yeah, no. And then if you do get that and you go braid something on top of it, you do what I call a direct braid on top of that.
Yeah.
Now you go laminate. And when you laminate, everything's melting. If you don't have your parameters perfect and you melt that liner layer, now you have braid on the inside of your catheter. So that can pose an issue, and that could go scratch a device. And, maybe you don't see it on 10 units, but, you'll see it on the 11th, So that process development to control that gets a lot more difficult. But I don't know. There's a lot of new interesting technologies coming out. So we'll see how it goes. I'm sure the PBACs will keep getting thinner and thinner, and easier to work with. So no, it'll be exciting to see where that all goes.
Okay. In your training, I suspect that one of the items that you'll be able to help people with, let's say a startup, is whether, make or buy, right? Do you get the equipment in-house to do this, or do you utilize the vast infrastructure of contract manufacturers? And I think you could probably help people in those decisions, right?
Yeah. That's always a tough one. When I went to Inari, coming from a contract manufacturer, one of the first things I did is say, hey, I want all this equipment. So, I can build all this stuff. And not every company is going to have the budget and, the trust to do that. But, I think there's a lot of pros to bringing things in-house, or a lot of perceived pros. You can cut down on timelines, you can cut down on costs potentially. And you can keep your trade secrets in-house, whether that's processes or other secret sauce you've got in your parts. Cons on their side, finding the expertise to run all that equipment, difficult. Great. Someone can do a single lumen braid, but, can they handle the rest of it? Do they know how to do a braid termination? Once you bring that stuff in-house, you got a bunch of new difficult processes you got to manage. So that's tricky. I think one of the big things too is, okay, great, you brought all those machines in-house, it's going great. Well, now all those machines are busy. And those people are busy. So it's like, okay, so that original pro where I could build in-house is no longer true because that equipment's busy. And now I'm essentially using my internal stuff as a contract manufacturer.
Yeah.
And then I think on the contract manufacturing side, you go to them, they've built hundreds of designs. So, and they've brought hundreds of designs to manufacturing. So you get that built-in process development right off the bat, easy peasy. I think the tricky part is that OEMs typically don't want to share all the detail. We talked about this earlier, kind of those contract manufacturers end up being a little handcuffed in their design. It isn't a collaborative effort. And I think there's an aspect to it where the contract manufacturers and the OEMs speak a different language a bit. I learned this when I was talking with doctors at Inari. It was a gift essentially that they gave us where we were able to go work directly with the doctors. And, the doctors say, hey, I need this, that, and the other. And it's like, okay, and now I need to reapply that to engineering terms. And I think a lot of OEMs do that to their contract manufacturers and vice versa. So I think it'll be great to train people on how to kind of collaborate in that space and make sure they're speaking the same language, understanding the problems, and kind of lifting the curtain a little bit too on some of what the contract manufacturers are doing. I think they're doing a lot of amazing stuff, and they really understand their machines. So looking forward to training people. If they want to bring it in-house, great, bring it in-house. If you want to learn what your contract manufacturer is doing, here's learn about that. So hoping to provide trainings to really help bridge that gap there.
Excellent. Okay. One of the things I was thinking about when you're helping R&D teams develop a new novel device, especially with Chamfr, you have access to all these different components where you can iterate quickly. On the flip side, I'm involved in an anchor balloon. It's a novel balloon anchoring system for tortuous anatomy. And, it's VC and just a startup with friends and family kind of invested in. You could kind of iterate yourself to death and burn money pretty fast on a startup. And is that, how do you, based on your experience, how do you manage that?
I think bring up Chamfr is a cool transition because there's like a lot of contract manufacturers do this really well. There's like the quick and dirty way of making something like, oh, hey, I've got some of these mandrels. I have some of these liners. Oh, let's check Chamfr real quick. We've got some materials there. okay, and by the end of the week, we can have something that's close enough for an animal lab, as opposed to going, hey, I need this made, 3 months later, you have your perfect custom thing. Well, okay, by the time you got that perfect custom thing in 3 months, I've gone through, 15 iterations. Yes, they didn't all look perfect, but, I learned this isn't going to work or that material isn't going to work. So I think I don't know. I don't think that's done very often, to be honest. I think contract manufacturers tend to do it well, or, maybe it's just Mike Schultz pushing in a better direction for that sort of thing where you can do things quick and dirty with the materials on hand. And I think Chamfr is a great resource for that. I think there's a bunch of great resources for overruns where, you can build something quick and dirty. And I think that kind of lends into that iteration process where if you can get a bunch done early on, that helps a lot. One struggle I always saw and hear about is management wants something very quickly on their strict timeline. And that isn't always going to work with the engineering process. And management likes when they can start seeing data and you kind of really start going through that waterfall. But that early design process where you're just on a bench making stuff is a bit of like a black box. And I think by training people on the different steps, training people how to do the quick and dirty R&D, you can kind of get through that black box a little faster, start going to animal labs, start showing things to doctors. And it really helps when management can start seeing those different things and different results from that process.
Okay, interesting. So tell us a little bit about, let me ask you one more question, and then you can talk about how people can get a hold of you for the training. I know I think you're working on a website. I went and looked. I don't think it's up yet, but hopefully by the time this podcast drops, there might be a link, right?
Yep.
Yeah. So just, kind of wrap up with one thing, and because we're talking about early stage and iteration, and if somebody came to you, a surgeon or doctor or somebody with a great idea with $2 million in the bank, tell us what advice you'd give to that person to either, how to go about the process.
Yeah, I think maybe first off, a little jokingly, you probably need more money. So go look for more money. If it's a class 1 device, that might work, and anything above that, you're going to struggle. But I think the big one, and like I said, the gift that Inari kind of gave was allowing the engineers to talk with the physicians and the nurses and the scrub techs and really understand that voice of customer. So, I mean, I think if you've got a really novel, great idea, you can never do enough voice of customer to understand the market, understand, your problem a little bit more, understand all your customers from the attending physician all the way to who's actually using it and the patients with the problem. I think that's all huge. And I also think at the same time, sometimes you come up with something that's too novel and the physicians can't quite see the vision. So you have to take it with a bit of a grain of salt as well. So there's a tricky balance. And then, from there, you got to find a good partner to help you build it. And that's a tricky process as well. But I think there's a lot of great contract manufacturers out there, a lot of great design consultants. And hopefully, CathTeam can help be a bridge between a lot of these different aspects of the field as well.
Excellent. Hey, Tom, and this has been a great conversation, and congratulations on your new venture, CathTeam, and we'll help to get the word out. And I think, like I said, there's a huge need for this, and I appreciate you getting out there and with this new venture.
Yeah, really excited. We'll be at MD&M as well in February, so got a booth, and really looking forward to launching this and offering the medical device field some new trainings, local, hands-on, with all the equipment you've got in-house as well. So really excited for it.
Awesome. Thanks, Tommy. Good luck.
Thanks, Steve.
All right.